Today in this video we will solve another NMR spectrum. First of all, the steps of to solve the NMR spectrum are the same. First of all, we will calculate the number of the peaks. Number of the peaks will tell the different types of the protons that are present or the different types of the carbons that are present in our compound. Determine the chemical shift value. Chemical shift value gives a rough estimation that which type of the functional group is present near to the R protons or the carbon atoms, and integration value will tell us how many protons or the carbons are present in one peak area. After this, we will combine all this information will elucidate our structure. Here, first of all, we will get the information from the IR spectrum. As you can see here, this is the IR spectrum. So here, no specific peak is present here in the IR spectrum. It means that we cannot get any information from the IR spectrum, or there is no functional group that is present in our compound. Here in the mass spectrum, we will get our formula, that is C8H18, and our molecular peak is almost at about 114 value, mass to charge ratio value, and then these are the other peaks, but our main concern is C8H18 is our molecular formula. Now here, if we see here, this is the C13 NMR spectrum. So in the C13 NMR spectrum, there are the two types of the NMR spectra are given. That one is depth and the other is proton decoupled spectrum. In the depth spectra, as you can see here, the two peaks that are upward in the upward direction, that will be due to CH group and the CH3 group, but the peak that is in downward direction, here is no peak in the downward direction. It means CH2 group is missing in our compound, or there is no CH2 group in our compound. Only the CH3 group or maybe the CH group is present in our compound. So here, if we see the chemical shift value, it comes around about in the range of about if you see here 0, 10, 20 and 30, means 0 to 30 range, and in this range our methyl group is present. And here if you see, these two peaks are in the same ppm value, and it is the proton decoupled spectrum. So it means that this means the maybe the CH3 group, and here this peak has no peak area in the depth. It means in the proton decoupled spectrum, this peak means that this carbon atom is not attached with any proton, with any hydrogen. Okay, here this so before in the previous spectras, we have the information that our compound has the molecular formula of C8H18, and there is no specific functional group, and also there is single C is also present in our compound, and two types of the carbon is already present. One carbon is single carbon, and the other carbon may be the CH3 group or the CH group. This is the information that we get from the previous spectra, and now in the proton NMR spectrum. First of all, we will see the peak. As the single peak is present, it means that only one kind of the protons are present in our spectrum. And now we will calculate the chemical shift value. Chemical shift value is almost in the range of 9 ppm value. It means that our structure is methyl group. Single peak is present, it means one kind of the protons are present, and also there is no splitting pattern is not there. So it means that in the neighboring there is no proton is present to which it can give the splitting. There is no neighboring protons are present by which it can give us the splitting by n+1 rule. So it means that this methyl group gives the singlet, and there is no neighboring proton is present. Okay, now we want to elucidate our structure. So first of all, there is no CH2 group, there is no CH group, because this is the single peak, and single peak is due to the methyl group as the ppm value shows. So only the methyl groups and the single carbon. These are two types of the carbon, and this is the one type of the proton that is present in our structure. And also the information that we get is there is no neighboring proton in the vicinity of this methyl group. So we have to elucidate a structure, or we have to find a structure that have this molecular formula and that have only the methyl and the single carbon atoms. So first of all, single carbon can only be present when there is 3 carbons. Okay, not 3, in fact 4 carbons are there. It means this is the our single carbon. Okay, now we have found in the proton NMR spectrum that there are only single kind of protons and total protons are 18. So it means that its integration value is 18. So here methyl groups are present, and as you can see, this methyl group, in the vicinity of this methyl group, the methyl group is directly attached with the single carbon, and here there is no proton. So now if we calculate our protons, these protons are total 9 in number, but here the number of the protons should be 18. And now if you see that this carbon is also attached with this carbon, but now the problem is that here two types of carbon is present, first carbon and second carbon. Now there should be some structure here. So if you see here if we attach the 3 methyl group, then now you will calculate the number of the protons. The number of the protons are 18. It means our protons are fine. What about the carbon numbers? Carbon numbers are 8, 1, 2, 3, 4, 5, 6, 7 and 8, and the carbon 8 is also fully satisfied. So it means this is the respective structure, and this respective structure is, if you see here clearly, you may find the name of this structure. Only the 2 types of the carbons are present and only 1 kind of the protons are present, or you may say that all the protons in this structure have the same chemical environment, and the name of this structure will be, this is 1 carbon, 2nd carbon, 3rd carbon and 4th carbon, 2, 2, 3, 3 tetramethyl butane. This is your structure. And the one most important thing here, you may see that all the protons have the same chemical environment. It means this will give the single peak in the NMR spectrum. This may be asked in the MCQs. And if you like my videos, then please subscribe my channel and share my videos.